Welcome back to the shop. I'm getting ready to start on a new project. It's a project I've been putting off for a little while, and since it's winter time, can't do anything outside anyway, I'm going to go ahead and start this project. Now, it's basically, I'm going to be making a 3D print, doing a 3D printed helmet, start to finish, just like these guys up here. Now, I've been making helmets for a long time. I think one of my very first helmets I ever made was a paper mache helmet. Years back, I also made some fiberglass helmets. Those were all foam helmet, or sculpted from foam block, and molds were made of those. I believe most of the time they were made out of plaster. And then I made helmet halves and then glued it all together and finished a helmet. This project is going to be a 3D printed helmet, just like these three right up here. Whenever I'm starting a project, especially when I'm doing a 3D print, I think the files for this guy I purchased from a maker, actually a very good maker, and I wish I could remember his name. This file is also a purchased file and then modified to be more screen accurate before it was printed. And this, I think this is a found file. I think I may have found this on Thingiverse or something like that. Printed, I'm not sure about that one. I think I may be a little too small on it, even though some of my measurements and whatnot. But we are going to get into that. However you start, whatever your plan is, whether you're doing Star Wars or any other cosplay type of helmet, what I'm going to be doing is a Mandalorian helmet, but I don't want any specific character. I kind of want more of a generic, it's a Boba Fett style helmet, but it won't have the dent, it won't have the mole on the cheek or anything like that. And I'm going to modify it because I would like it to have the ability to be set up in different ways. First off, when you are selecting a mold, I like to use a lot of reference. This project doesn't need any reference. It just needs to be a good, well-balanced, good-looking helmet, and that's pretty much what it is. But these guys, especially these guys, referencing is very important. Most of the time I'll physically modify them if possible. It's easier for me than to try to modify the files themselves. I am going to get into scaling, making sure it fits your head, all kinds of different stuff. First off, is I already have the file in my computer, and I am going to go ahead and pull it up, start slicing that file. One of the things I want to make sure is it'll fit my head, and I kind of have a reference size that I like to use, especially for Mandalorian helmets, for it to fit a lot of people's head sizes. I don't want it monstrous, but I don't want it so small that it fits a less number of people. So I already have that number in my head. Let's get to the file and start messing with it in the computer. All right, here we go. Now I got it in 3D Builder. So what I'm going to do is I'm going to import it and spin it around here, look at it. See, so it's just basically a generic Boba Fett style helmet. We are going to change some things on it, but we're going to change them in the physical world. I'm going to make physical changes to this model once it's all printed out and I have it assembled. So first thing I want to do is check its dimensions. I want to see how wide, how tall it is, and all those things. 250 on the X, 236 on the Y, and 267 on the Z. Now, I've already checked the measurements on this. Actually, the measurements are exactly where I want them, but this is the point where you would check to see if it will fit. So one thing that I do is I use a set of calipers I 3D printed. These are great. They're able to let me measure my head and all that kind of stuff to make sure that something's going to fit and something's going to work for me. I also use, in conjunction with it, I use a standard ruler that has centimeters on it. So if I wanted to check the x-axis, which is 250, it's actually 225 centimeters. So I'll just stick it right there and move this all the way out to 25 centimeters, and that is on your X, so right here. So that gives me, I tell you right now, that gives me plenty of room. It'll fit. And you do the same thing for all the other axes. The places you want to measure, like if you're measuring your own head, you want to cover your chin and then the top part of your head, and then you make those. So you can create your own measurements, sideways, front to back, and height-wise. When people commission, which happens a lot, people will commission me, even though I don't do that, but I have a larger printer that allows me to print helmets in one piece, and not a lot of people have that, or they're getting more and more popular and more affordable, so more and more people have them, but still a lot of people in my community do not have them, and they ask me to print their helmets for them, and I always ask them, what are the I need measurements for your head, and they tend to always send me a hat size, which is fine, but it doesn't work if you're making a helmet, because the hat size doesn't take into account your nose, and most of the time your ears. Those are the measurements I want, between your ears, from your chin to the very top of your head, and the nose to the little bulby part on the back of your skull. Those are the measurements I want. But anyway, back to the computer. Now that I know that this is scaled properly and it's going to fit for my needs, I'm going to cut it up. The reason why I'm going to cut it up is, for example, a lot of people don't have the ability for it to fit on their printer, so I'm just going to go ahead and cut these pieces up. I'm only going to cut this into 3 pieces. I just want less seams to clean up, but this can be cut in to 4s, 8s, whatever fits your computer or your printer, I'm sorry. What I am going to do is I am going to avoid any major body lines. So I'm going to cut the dome off, but I'm going to cut the dome off without interfering with this line right here, that seam right there, or that visor, the line above the visor. I'm going to cut it right off. And also I'm going to avoid a few other things. So I'm just going to go right above the triangles, and that's also going to stay out of that right there. Maybe bring it down just a hair. Look around the back, make sure you're not getting into anything in the back. Not getting into anything in the back. Although I am right there getting into that right there, so I'm going to move it up just a little bit. And now I'm going to split. Now I'm just going to turn it this way. I'm going to highlight the bottom half, and I want to split it also. Now, the reason why I'm going to split it this way and not another way is I don't want to have to rebuild the keys here, and splitting it right like this gives me a nice clean line that I can put it back together. I don't have to worry about the, going in between the arrows or whatever. And you can split, even though you may split pieces unevenly. When you do split pieces, you can split them in a way that you avoid any extra work. Like having a few extra split lines still would save you, just by cleaning up an extra set of lines, would save you from having to glue it and seam it back together and then clean the seam in the keys right here. Instead of splitting in half, you could split along here and along here to make a smaller piece, turning this into 3 pieces instead of 2. And then a front, I could split right up the middle if size required for my printer bed. We're going to put all this on a large printer bed. I'm going to arrange all this on a larger printer, so my printer would have no problem printing this all at once, but we're going to print it in pieces, so we'll have those pieces. I'm going to go ahead. I've already saved all these pieces in this cut form, so I'm going to close this out. All right, now I've got all these pieces. I brought all the pieces over to Ultramaker, and first thing I'm going to do is I'm going to take this dome and flip it over. I'm also going to take the front face, I'm going to flip it over, and I'm going to take the back end and also flip it over. I'll switch, Let's move some of these parts around and get them better oriented on the deck. There we go. Now, there we got them all oriented. Now, I'll tell you, the reason why I'm flipping them upside down is whenever I have sliced models, not all 3D printers are created the same, and over time, not every stepper motor and belt and everything is perfectly tensioned or in the perfect operating fashion. I always orientate my parts as best as I can. These parts should be orientated a little bit better along the same axes. Flipping the face parts over gives me a cleaner surface, and they're not going to sit crooked, and they're also not going to be very little supports in flipping them over. Now, the dome is flipped over because it actually saves on supports. It's only going to put a little bit of support on the bottom of the dome, and then the dome's going to support its own weight going up. If it was flipped over, there would be a huge cone or tower of supports going up the middle to support the top of the dome when it gets there. Uses more material. I don't worry about that being on having to clean those supports off the outside. I'm not worried about that. That's the outside of the helmet. It's going to be easier to knock that down. Sometimes it's easier to most of the time it's easier to take it off the exterior of the helmet than it is on the inside. Like if I was going to print this all one piece, I would still print it upside down. Anytime you can save not having supports, it's a good thing because it just saves material. Because you're just going to take the supports off and throw them away. So if you're going to arrange something to minimize the supports, that's the best thing. So I'm going to slice this and then input it into the 3D printer and let the 3D printer go. All right, that only took 2 days to print. So here it is. We have the face plate fresh off the printer. We have got the dome fresh off the printer, and of course the back plate. You can see I got to work on my settings. They're a little stringy, but next step is let's get rid of all the supports. I may not get rid of all the supports. I may get rid of some of them. The pieces are a little bit thin and fragile. This print was this file was a file I had made by a friend. I even told him, I don't need it double walled. I just want a single wall. I think it's 2 millimeter. It suits my needs it suits what I need. So cleaning up the supports, since this is a little bit thinner, I need to be a little extra careful on cleaning up those. I have this flathead screwdriver. It doesn't fit any of my sets. I've had some of these older wooden ones, but this one's always been sitting around, and I actually sharpened it. It's not like super sharp, but I took a lot of that off, and this has turned out to be one of my most favorite tools for removing supports. It kind of gets down in there really good and allows me to just kind of get underneath them and keep working around, and it allows me to get really close to where they're adhered. I think I used a brim on this. That's what this is. This was printed in PLA. I tend to use a brim on PLA still, even though it's not 100% necessary. So I'm going to clean these supports off. And as soon as I'm done, as soon as I get the supports off, I'll get right back to you. All right, and we're back. I didn't clean this off yet, and the reason why is I actually might end up using it to allow me to stand the whole helmet on its top. And I didn't clean out the eyes or the visor area right here. And the reason why I didn't do that is adding a little bit of stability and strength to the helmet right now. These Mandalorian helmets, when you have everything out, they're very weak, and there's not a whole lot holding it together. Probably about an inch worth of 3D print on each end, and just to be on the safe side, I'm going to leave that intact, and probably once I get all this glued together or welded together, I'm actually probably going to put a piece of plastic, glue it between the two here to help support the helmet during the sanding and all the body work and everything we're going to do to it. But getting to putting these together. Now, I take them and I put the seams together, and I look at the seam and see if there's anything I need to do in case it's not fitting tight or it's having a problem fitting. And that does happen a lot. There might be supports in the way. There might be a little bit of this or a little bit of that. So what I like to do, one of my favorite tools for this is actually just a good old-fashioned file. Files are nice. They're a nice flat surface. So if you take them and run them down your project, you can actually see what's not straight. And also, they'll attack the high spots and leave the low alone until it gets to that point. So that's what I'm going to do to each side, each one of these seams, is I'm going to run the file down them and check them, see what they look like, and then file them smooth. Alright, now since I only have my two hands, I'm going to clamp the halves together so I can start the process of joining them together. Alright, once I have it clamped together where I like it, I'm pretty happy with this. This is what I like to use. I like to use a 3D print pen. They're fairly inexpensive, and like I said, it acts like a plastic welder. Now, when I'm joining PLA parts together, I'm actually setting this at ABS. It's a little bit hotter, and that allows a better melting of this is actually the exact same PLA that this is made from. It makes it a little bit hotter and makes the bond that much stronger. It actually makes a pretty nice bond, and if need be, I may run this along the outside seams also, and then we'll work that all down. But we're going to see how the seams look. So as soon as this warms up, we're going to start to weld this thing together. So I actually hold it for a minute or two so the material has a chance to cool down and hold everything together. Now, I'm actually going behind this also. You can see right here that there's a difference in the height of the parts. I don't know how well you can see that, but I'm pushing one down and holding one up. Still holding it, make sure it stays in place. The tip burns its way into the plastic. So when you're going down it, like on the outside seams, I might go fast as I possibly can. Not fast as I can, but much faster than I do on the interior. When this is all nice and cool, I can always come back over it, rough file it down. But we're going to get to that. Now let's get the dome on. Now I'm going to line the dome up as best as I can. I'm going to tack it in a few spots. So a dome actually doesn't fit all that great, but it's kind of like one of the things you do kind of run into in 3D printing is not all your seams are going to match up perfect, but we're going to reinforce this seam from the inside. There we go. All stitched together. Looks pretty good. And it's still, I can still sit it upside down. Seams are done. They look good. They're nice and strong. I think this is a perfect time to stop. So see you next time when we start doing body work.